Corporate finance practice problem using OneNote future value calculation comparing the compounding of annually versus quarterly versus monthly. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're in the tab on the left-hand side. We're in the practice problems, then down here in the 936 future value compounded annually, quarterly, and monthly tab. Also note that if using OneNote, you might want to take a look at the immersive reader tool. Many of our presentations up top will also have text items down below, which will be transcripts that can be translated into multiple different languages and both read and heard in multiple different languages using the immersive reader, making them a good complement to the presentation sections. Closing this then back out, we're going to have our information up top. We're going to be working through the practice problem down below, doing multiple calculations for it, and we will be comparing then the compounding of our problem for annual, semi-annual, and quarterly. That's going to be the major focus that we will have. We'll look at some of those differences with multiple types of calculations, including mathematical formula calculation what would look like basically in Excel, how that might change, and then with the tables. So we have a future value of the 15,000, years are going to be 10, and then the percent is 8%. We'll start off with the annual, which is going to be the easiest because we don't have to basically make any changes to the years and percent. Then the semi-annual, where we do have to make a change and consider what the years and percent will be, and then same with the quarterly. We'll start off with the mathematical formula, which is the future value equals the present value times 1 plus r to the n. So we're going to have our information down below. We're going to break this out into basically a table type of format. We're going to start with P in the outer column, the PV, which is going to be the 15,000 from up above. And then we're going to have the 1 plus r to the n, this component. So it's going to be 1 plus r, which is 8%. That would then give us the 108%. And then we're going to take it to the number of periods, which is 10. Let's do that calculation using a scientific calculator, which you can get to in your Windows calculator by going to the drop down on the side, scientific calculator. So we have we're going to say the 1 and then plus the 0.08. That's going to give us the 1.08 or the 108%. We're going to take that to the power of n then, which is going to be this icon down below, this icon, to the power of, and there's the little caret, the 10. That's going to give us the 2.15.892 and so on. This is in decimal format. This is in percent format as opposed to the decimal format up top. Then we now have these two items. We can multiply them together. So we're going to take that, multiply times the 15,000. That's going to give us our 32,383.87. Going to convert this back to our standard calculator and make it a little smaller so it kind of hangs out up the top there. And then we're going to scroll on down and say, well, what if we did this calculation using the future value of one calculation, this time using the semi-annual. So we'll do the same comparison now. Last time we used the annual, this time semi-annual with the mathematical type of format method. So now we've got the 15,000, and then we have the to the power of, we have the 1 plus the 4%, and that's where the difference is going to be. So now we have this percent is a yearly percent. That's typically how percentages will be presented to us because yearly percents are going to be within a relative range. If you start talking about semi-monthly percents, or semi-annual or monthly type of percents, the percents get quite small. Therefore, for communication purposes, the default typically is that we're going to say the percent is in years, and then if you need to change it to some other percent to match the period that we are using, we must do so. In this case, this is the yearly rate. We got to break it down to a semi-annual rate, which means we could take it, divide it by 2. That's going to be like the 6-month rate as opposed to the 12-month rate. That gives us the 4%. Then we're at the 104%. Same thing with the periods here. Now we have the periods at 10 periods, but we're going to be compounding semi-annual. Therefore, we're talking periods of not a year, but 6 months. So there's twice as many of them, and that will give us the 20 periods. So these are the two changes. And then if we take that out, we're going to get to the 219.311231 about multiplying the 15,000 times that number gives us the 32,866.85. And you can see that number, how it differs from the number up top, 32,383.87. So you'll come up to a different number. Also note that when you're comparing these types of things, people can kind of be tricky or play games with these percentage rates. So in other words, if we were to say we're going to compound semi-annually, and someone said we're going to use the same rate at 8%, but now apply it to a semi-annual rate, well, then we'd have a much bigger difference in this problem, because we'd be using an 8% rate for 6 months as opposed to an 8% rate for an entire year, and you'd come up with a much different number. So what we're doing here to kind of compare similar to similar, like to like type of situation is we're saying, well, that's the yearly rate. If we're breaking it down to a 6-month item, we got to take that to the 6-month rate, which would be to take it and divide it by 2, and then we'd have the 20 periods so that the periods line up to the rate. So that's what you got to keep in mind. Make sure that whatever rate you are using, you have the proper rate that lines up to the period that you are using. The standard or default rate is typically a year. If you have some kind of compounding other than a year, then you're going to have to figure out what the rate should be in that situation. So if we go back down, let's do the same thing, this time quarterly. So now we're going to be compounding quarterly, doing our formula. So we got the 15,000, same thing there. Then we got the 1 plus, now the rate is now 2%, because we had the 8% for a yearly rate. If we're given the yearly rate, but the compounding is happening quarterly, I need the rate per quarter, per 1/4 of a year, per every 3 months, in other words, which would be the 8% divided by 4, or 2%. That would give us the 102. Then we need the number of periods. If they give us the periods in years, 10 years, and we need to compound quarterly, then we need to break that out into the quarterly components, that being our period basis being the quarters. So we'd take the 10 times 4, and that would give us the 40. And then we do our same calculation down below, the 15, and that times that gives us the 33,120.59. You can see how that then compares slightly different, or it will be different than the calculation up top when we have the semi-annual, and calculation up top when we have the annual kind of numbers. Again, be careful with people being kind of deceptive in terms of applying the same rate and saying, well, now it's the same rate, but now it's quarterly versus semi-annually versus annual. So you want to just be careful of that rate and make sure you're tying out the rate to the proper period. So then if we go down again, let's do the same kind of thing. Let's look at a running balance, and you can get a good idea of the differences in terms of the whole layout as it would fall in a running balance. Highly recommend doing these in Excel. This is something that would be tedious to do, without Excel, possible, but with Excel, easy to do, or any kind of spreadsheet can handle this. So in the yearly method, if I was to break out these periods on a yearly method, these periods stand for 10 years. If I'm compounding yearly, then I can simply take this 15,000, for example, times the rate, which we said was the 8%, times the 0.08. That would give us this 1,200, that 1,200 plus. That's not plus. Hold on a second. Let's do that again. Then we got the 15,000 plus the 1,200, and that would give us the 16,200. Taking that times the 8%, 0.08, would give us the 1,296, 1,296. Adding that then to the 1,7496. Sorry, let's do that one more time. Adding that then 16,200 plus 1,296 gives us the 17,496. Let's do it one more time, see if I can do it cleanly. Times the 0.08. That's going to give us then about 1,400, and then adding that to the prior balance of the 1,7496 would give us the 18,895. If I did that same kind of thing, but then compounded semi-annually, now I would take the 15,000 times, and I could do it this way. I could do this multiple ways. I could say times the 8%, 0.08, but that would be for a year. And then if I want to break this out to a half a year period divided by 2, then I'd get the 600. So this first period then represents 6 months instead of 12 months. And that would then, of course, be 600 on the interest. The 15,000 plus the 600 would give us the 15,600. We can also do that calculation this way. We could take the percent, 0.08, divided by 2, getting 0.044% being the semi-annual rate, and then multiplying times the 15,000. Note that when you use Excel or something like that, you often use that method, but when you use Excel or something like that, it can deal with small fractions easily, even if you can't see them. That's why working with small rates isn't really a problem with computers or Excel. Whereas if you're doing it by hand, it could be a little bit more difficult, right? So that's why when I do it by hand, normally I would do it this way: 15,000 times the yearly rate, 0.08. That would be the interest for a year divided by 12. That would be the interest for a year divided by 6. 15,000 times 0.08 divided by 2 would be 600. So then if we got this, let's do it one more time. The 15,600, multiplying that times the 0.08, that would be the yearly rate, would give us that, divided by 2 would give us this 624, and so on and so forth, and that would then go down or out to 20 periods that are 6-month periods as opposed to 10 periods, which would be yearly periods, and you can see the difference in the results here. Let's do it again, this time for the quarterly. So quarterly would look something like this. Now we got the 15,000 times 0.08, which would be the yearly rate. That would be the amount per year. Now I'll take that divided by 4, giving us the 300. We can also do it this way. We can say, well, 0.08 is the yearly rate divided by 4. 2, or 0.02, would then be the rate for a quarter times the 15,000. And we get the 300 again, plus the 15,000. That's going to be the 15.3. If I take that 15.3 times the 0.08 yearly rate divided by 4, that's going to give us our 306, and so on and so forth, adding that up down. Now, of course, this starts to get quite long, where we have 40 periods. It would be tedious to do that by hand. With Excel, very easy to do. Then let's go down, let's see how this would apply for an Excel type formula. So we have to change the Excel formula a little bit and beware of these adjustments as well as we enter the data. So it would look something like this. This would be a future value calculation. The rate, if we're doing it annually, would simply be the rate, which would be this 8%, that cell, plus or comma, number of periods would simply be 10, then comma, because we're doing a present value, would be the B2, which would be the 15,000. Now let's go to semi-annual. What's the difference in semi-annual? The rate now would be the 8% divided by 2. So you got to make sure to pick up that divided by 2. Again, note that Excel is taking this yearly percent and dividing it by 2. That's kind of like the method it's using to calculate this. We used a nice even rate up here, so if I divide it out, it divides evenly. But oftentimes that's not the case. You could end up with some decimal or in Excel and some small number, which is harder to deal with. But note, it's easy to deal with Excel. Excel will handle the decimal and calculate it for us and be okay with those small numbers. Whereas if we calculate it by hand, we're probably more comfortable dealing with yearly rates and whatnot when we can. So then we have the comma, and then we have the number of periods. The number of periods now would be 10, but now it's semi-annual, so 10 times 2. So now we have the 10 times 2, and then comma, and we have the same B2, which is the 15,000. If we did this quarterly, we'd have to do a similar adjustment. We'd have to say this is going to be the B4, the rate, which is going to be that 8%, but now it's quarterly, so I got to get the rate tying out to the periods. It's quarterly, so the 8% divided by then 4, comma, number of periods then is going to be the 10 periods. Once again, it's not in years, but quarters. Therefore, the 10's got to be times 4, just like it was times 2 up here for 2 years. And then we're going to say comma, same 15. So you got to be aware of that with the formulas to magically get the proper numbers fed out to us. Let's take a look at the tables then. Table time, same thing on the table time. If we had the normal annual rate here, we got the 15, looking up this amount on the table, it would be 8 and 10, 8% and 10. So 8% and 10, that's going to be that 2.1589, 2.1589 that has been used here. Then if we look at it semi-annual, I got to do my same thing when I look at the tables. Remember that these tables down below do not represent like yearly rates. These periods do not represent years or months particularly. They just represent a period and the percent applied to that period. Note that when you're talking about periods that are something other than a year, it becomes more difficult to use the tables because you need to use even interest rates in order to effectively use the tables, and you're limited to the number of periods. When you're talking about periods that are months, for example, then you're going to have a whole lot of periods and it can quickly go past the table, and you're often going to end up with percentage rates that are small and or have decimals related to them, restricting the use of the tables. So if I go back up top, we're going to say then if it's semi-annual, then we'd have the rate would be 8% divided by 2 or 4%. The periods would be then 10 times 2 or 20. So I'd have to say 4 and 20. So we're looking 4 and 20. And that would be the 2.1911. 2.1911 is what's being used there. And then if it was quarterly, similar kind of thing, I'd say, okay, well now that 8% is a yearly, divided by 4 would be 2%, 10 periods. But if it was quarterly, times 4 would be 40. So now we're looking 2 and 40, 2% and 40. So it'd be 2% and 40, which is way down here, 2.2080. So 2.2080.